apparently I'm doing DataOps. So this is a story about my DataOps journey, which I started on, I think, about 2.5 years ago. Kind of unknowingly, coming from a DevOps background, I work for a company called FullStack. We are a cloud native company, doing all kinds of things cloud native, mostly with Kubernetes and also with running things on Kubernetes. And a client of ours came to us with a problem. They had a problem with a data ingestion pipeline that they were running. And I was asked if I could solve this issue with this pipeline. And that turned into kind of an interesting journey, which I will share with you today. So the use case itself. There was an ingest application written in Python, running on a virtual machine somewhere in the internal network. And this ingest application was taking data from source databases. It was doing some aggregations on it, some transformations, doing all kinds of stuff with it, and then outputting this into the internal data warehouse. And then from this internal data warehouse, this data was then picked up by an R server, which was running on the Google Cloud environment. And then this R server was also doing all kinds of things with the data, more aggregations, more transformations, more like obfuscated stuff. And then it was outputting this data again into another data warehouse that the actual business users and analysts were using, which was BigQuery. And this ingest application, or better yet, this ingest pipeline had a couple of issues. It was very error prone. There was no version control. There was also no quality assurance over the stack. So there was no unit tests, no integration tests, also no end-to-end tests for any of the components. Well, there was a little bit of version control in the case of the Python applications which was put into GitHub somewhere, but that's it. And also there was no visibility over the stack. So when something actually did go wrong, it usually showed up at the end user side in the dashboards. Or if we were very lucky, it would show up in the BigQuery data warehouse itself when people were doing analytics and they were seeing, oh, there is some data missing, or data is not correct, or apparently this table has been empty for over a week, and why is that the case? And then somewhere within this pipeline, there was an issue somewhere, and every time you just had to dig into it. So this wasn't working. We had to fix this. We had to come up with a solution for this. As I said, I came from a DevOps background, so I was doing mostly infrastructure automation, release management, working more with developers on microservices, stuff like that. So data engineering was new for me. So data engineering, what even is it? What is the paradigm like? What is ETL, which apparently stands for extract, transform, load? And why do we now want to be doing extract, load, transform? And then what is extract, load, transform? Also, what is the ecosystem like? So what are people usually using? But also what should we be using? So like what is old, what is new, what is legacy? Our end users were using BigQuery. So are there certain limitations there that we should be taking into consideration? How is BigQuery currently being used? Like all these kinds of questions. What if we want to do batch data loading? What if we want to do streaming data? And also for me, very important, does Kubernetes have anything to do with this? Because I have been using Kubernetes before. I have been using containers before for doing tests and doing all kinds of things. And does Kubernetes also have a place in the data engineering landscape or paradigm? So lots of new stuff. Lots of new stuff to dig into, lots of research, lots of questions for which I did not have an answer. But I mean, at a certain point, there was enough information to start working on a design. So we basically had like a simple use case, right? We wanted to rebuild the current data streams. Simplify it, just needs to run, and we have Kubernetes available. But the most important thing was that whatever we started to build, we had to get the principles right. So the principles of good software engineering, it had to be modular, it had to be reliable, it had to be insightful, version control, all that kinds of stuff. So we then rebuilt the ingest application and ingestion pipeline into like a stable foundation. And basically what we did was we rewritten the ingest application to be very lean and mean. So no more transformations, no more aggregations, just take the data from point A and move it to point B. That's all you need to do. And we were running this on Kubernetes. Kubernetes was available to us. It had already a lot of the authorizations. A lot of the network was opened for us to use to connect with databases, stuff like that. So it was like a really logical choice for us to use Kubernetes, also because the ecosystem around Kubernetes in terms of monitoring and logging capabilities was already there. What this ingest app would then do was take this data from the source databases, move it to a storage bucket with some metadata, and then using this metadata, we had a cloud function that would then pick up the data in the storage bucket and then write it to a certain destination in BigQuery. So very simple, very lean, very mean, but we got the principles right. So we had version control for all components. We made sure that we had continuous integration tests, so CI running for all the components that we developed. Infrastructure as code. So we were using Terraform now to deploy and manage all the components of our infrastructure, both the deployment of the Ingest app, our namespaces on Kubernetes, other resources, storage buckets, cloud functions, BigQuery tables, IAM permissions, you name it, we all orchestrated with infrastructure as code. Environment isolation was also a thing that was missing, which we implemented, and also monitoring and alerting over the full stack. So here you already start seeing a little bit like a little bit of the DataOps paradigm starting to show, where we are using good software engineering and DevOps principles and applying it to a data engineering use case, which I think personally is one of the pillars of this DataOps thing that apparently we are doing, or apparently I am doing. And that was a very exciting time because now it was time to scale. So first it was just me as a single person, and then my colleague Johan joined, who is an amazing engineer, and now we had a team. So we were scaling the team, we were scaling our pipelines, and we also started to scale our use cases. But this also meant that our little Python application that was meant to be very lean and mean started to grow up. So it was no longer just ingesting and moving data around, but it was now also scheduling other ingest jobs. And we had an executor for that as well, which was talking directly to the Kubernetes API to schedule and manage these jobs. We also had a small validation component, which was trying to ensure that the data adhered to a certain standard. We had a SQL proxy put into place to ensure that we could do stuff like caching SQL queries, for example. We had multiple storage buckets. We had multiple cloud functions now. So on a whole, our system was growing. Our team was growing. Our pipelines were growing. Our use cases were growing. But also the complexity was increasing. And it was at this time that we had to reevaluate, because one of the principles that we try to adhere to is that we should do one thing and we should do it right. And our Ingest app was doing many things now. It was doing ingestion, but also orchestrating. It was doing validation. We had a SQL proxy attached to it, but it should just do one thing and it should do it right. And we have always been very pragmatic about this approach, right? So build for the solutions that you can see based on facts that you have. But at a certain point, it's always good to take a step back and see, are we still doing the right thing? And in this case, we weren't. At this time, we implemented Airflow into our environments. So Airflow is a workflow management system written in Python, usually used for running data jobs, data workflows, or data pipelines. And once we implemented Airflow running on Kubernetes, our ecosystem started growing rapidly again. We were now doing batch jobs. We were orchestrating streaming jobs. We were talking to all kinds of different cloud interfaces. We were moving data to PubSub. We were moving data to storage buckets. We were pulling data from multiple cloud environments as well, from Azure, from AWS, from other third-party APIs. And this meant that we now had another, our base was expanding to go upon. So our ecosystem was growing, but most importantly, our culture started to grow. So our team grew again with an analyst. So we now had like a multidisciplinary team of people really working together on the same domain issues. Also, other teams were starting to find us. So other teams with data engineers, but also analysts, business users were starting to use our platform. And it was at this time that we had like a platform that was built on principles. We started to get like awareness of this platform and of what the things we were doing, and also the way in which we were doing them. So this knowledge that was being created and generated within our team was also being shared to other teams. And for me, these things all boil down to a culture that is creating. And that's basically what we are trying to do with DataOps. We are creating a culture where people solve shared problems together and grow together. So, like I said before, we now have a culture where we are not just solving the issues at hand, but also a culture where we are building tools to enable other people. So we were now starting to get like other requests from within the community where, for example, analysts wanted to have a standardized way to add materialized views. People wanted to start creating and maintaining their own tables to do like tests and stuff like that. So we were now building tools to enable people, which I think is like one of the most beautiful things in the world. Also, new culture equals new challenges. So we were building tools to enable people. We had a new culture, and from all these things, also new challenges arise. So we were starting to see data more as a product, which means that we get a whole slew of like new challenges to look into. One of them is data discovery, data quality, data observability. So how do we make sure that we can describe what's in our system in terms of data? And also, how do we assert that the quality of this data that we put through a system is correct? And then who defines if this is correct or not? Can we as engineers do that, or is it the business users who should do that? So lots of new challenges. And that means that like we have arrived at a new data frontier. So a frontier where we have new challenges, which require new solutions, which also require new methods of working with data, looking against data, and also new tools which implement some of those methods and ways of working. And in the meantime, our team kept on growing and growing. And that was the point where I could look back and see that apparently I'm doing DataOps. But it's not just me, because it's really a team effort. We are doing DataOps. We are doing DataOps as a team. We are building a culture where people care about the data and where people care about the things they build and the solutions that they provide. And I think that's a really, really beautiful thing. But that was about half a year ago. So we went on this journey together, from solving a simple ingestion use case into building a platform based on principles, growing a team, doing lots of iterations as well, taking steps back, re-evaluating, re-implementing or refactoring solutions, and just scaling out. So scaling out our culture, scaling out knowledge, scaling out the team, our solutions, our use cases, and growing this DataOps culture. And it's funny because you always try to like put like maybe a finish line some way ahead, but this really feels like now we are at the starting point. Now we can really start taking on these new challenges. So I want to dig a little bit deeper into two of the challenges, like the specific DataOps challenges that we took up, which are data discovery. So defining what is this data that we have in our system? What is it doing? Why is it the way it is? And also, how can you find it? So having a system of data that's like self-describing. And the other one is data quality. So how do we assert that the data that goes through our systems and that's in our systems is up to a standard? And then how do we define that standard, and also who defines the standard? So first off is data quality. Some of you may be familiar with like the term garbage in, garbage out. So when you put garbage or crap into your system, whatever you try to build on top of that is also going to be crap. So for that, we want to be able to assert a certain quality over the things we build, the things we provide. And data, I mean, data is the component within our system. It's the thing we ingest, it's the thing we work with, it's the thing we base our realizations and our analyzations upon. So it should be correct. The quality should be okay. So we need to define tests for our data. We need to make certain assertions about data when it moves through our systems. And we shouldn't just be doing this at the beginning or at the end of our pipelines, but also in the middle, or ideally like each step of the way. So we had a notion of what kind of tests we wanted to provide, at least some standard ones. So for example, fields have no empty values or no duplicate values, maybe for some columns. Also, timestamps apparently are like very difficult in a legacy system. Apparently, everybody has like their own notion of what a timestamp should be and how it should be formatted. But for us, it should just adhere to a standard, ISO standard. So these were just like an example of some standard tests that we want to define. But the most important thing that we should support is the complex custom ones. So these are the ones that analysts and data scientists and the people with like the domain knowledge say, this is really what defines the quality of the data. This is what defines if the data is really the way it should be. And it's just an example here, like value of X may not exceed Y based on A plus B over a certain period of time for this certain batch of data. So these complex tests are really important, and it should be something that we should support. And we should then be able to implement this into our data workflows. And also when I say like we need to define tests, it's not just the engineers who need to define tests, but it's also the analysts and the scientists. So we should have a way to implement these tests in like a standardized way that's also familiar, not just for us, but also for them. So make it very easy to work with, really enable them to define these tests for the data. Regarding implementation, so how do we go about this? We looked a little bit into building our own. I mean, we had built like a little validation framework before in the Ingest app. That turned out to be complex really fast, so let's not do that this time around. We also looked into Great Expectations, which is a data testing, or better yet, a data expectations framework, also written in Python. And that has been around for, I think, a year now, maybe a little bit longer. But for us, that was actually a little bit bloated and didn't really fit into what we were trying to do. We wanted something that's like pluggable and very, very simple, again, very simple as well. And also the way of defining tests in Great Expectations didn't really fit with our way of working. So we ended up looking into Soda SQL. It was actually Mehdi Waza, shout out to him, engineer which I've met via LinkedIn, who pointed me out to Soda SQL for data testing. And we ended up using that. So Soda SQL is also a data testing framework written in Python. And what Soda SQL does is it extracts metrics about your data using SQL from the tables. It's very easily configurable using YAML, which fit into our configuration standards that we have for the rest of our components and for the rest of our pipelines mainly. It also has lots of out-of-the-box default metrics for checking if there's duplicates or missing values or row counts. It's very pluggable, so it's easy to plug into our existing infrastructure, into our existing data pipelines. And it has a very, very clean and reusable Python API, which for us is really important because we tend to want to pick the bits that we want to use for modules and then reuse them in our pipelines. And so the SQL makes this like very easy and makes it a very lean and mean tool for doing data testing. But the most important thing is that it supports custom metrics using SQL. So these complex custom tests that we should be supporting, we can just directly input them or extract those metrics using SQL, and we can just put it into the configuration file, and then so the SQL will fire those tests or basically that metric extraction onto the table, and then you can use those metrics to do all kinds of tests. So just the thing we needed. Implementing it into our workflows. So we have a configuration object. This configuration object defines basically how our data pipeline is going to be generated. So this configuration object can have dependencies, which can be anything from storage buckets if a file is already there, or maybe if a certain data set or table is there, or a certain partition in a table, or even if a different flow has those dependencies in the configuration. We also define destination, so where does the data need to be output to, the schema that it should adhere to, etc. Then we have a query to build the data. So in this case, it's going to be about refined data. So we need a query to define how to build this data, how to aggregate it, how to maybe transform it, and then this data is output into a staging table. And on this staging table, we then fire data tests using our Soda SQL configuration. And this configuration is also just part of the same configuration YAML. So that makes it very, very clustered as well. So that's like simplified version of this data workflow for creating refined data and testing this data. And then the next challenge that we had and wanted to tackle was data discovery. And it's kind of like a broad subject, especially in like a legacy environment where you have a lot of systems who are generating data, who are storing data, that are working with data, maybe transforming and moving that data around. For us, basically, this boils down to one problem, and that is that to do anything with data, we always have to fall back on people for everything. And of course, you need people. You need people. I mean, they are our starting points, and they are also our endpoints, and we need them in the middle. We need them everywhere, but you should not need them like for everything always each time. So we should not need people for answering questions about where the data is coming from, or when we want to know what data means, where we want to know who owns the data, or who owns the system that is producing the data, or who is then owning the pipeline that is outputting data into that system. We shouldn't have to go to people to ask these questions. We shouldn't have to ask them who is using or depending on the data, or figuring that out when something breaks and they come to us. And also, we should not have to ask people every time when we need to know which data we can use or which data somebody can use to reach a certain conclusion or do a certain analysis on. And it's especially annoying when that person is then referring you to a different person, who is then referring you to a different person who is then on holiday or does not work for the company anymore. So some of the things we want to solve by having data discovery. But the solution for this is complex, because you have all these systems and you have all this data which needs a description, and what does it even mean, and how do you tie that stuff together? Like it's just complex when not starting from scratch. But we can start simple with solving this problem by, again, like providing a stable base, a stable foundation to build upon, like the holy grail of data discovery. Or, well, data discovery is like the holy grail, but you need some stuff for that, and you can start very simple. So we start by just being descriptive, like describe everything. Describe the schema, describe the columns in the schema, describe what those columns are for, what you can use them for, what they do. Describe the queries. Why is a query the way it is? Why are certain things done in the query the way they are being done? Have documentation for the pipelines, be able to describe the pipelines, etc., etc. Be descriptive about every component in your ecosystem. Enable metadata, so label everything, label your queries, label the pipelines, label BigQuery tables, label everything. Put in there who's the owner, who manages the data, what's the source system, etc. Start logging lineage. So we want to be able to answer the question, why is data the way it is? So why is data a certain way now, and which steps did it take to reach that state? I mean, you want to be able to answer this question as well. So log lineage, and there's multiple ways of doing that. One is by inputting the metadata everywhere, or maybe logging pipeline steps to a different table, which you can then aggregate upon again. Enable usage statistics. So for us, this means that we are using audit logs to determine who is querying certain tables and how often are they querying those tables. And then all this information together helps you answer the questions. What does this data mean? Who is using this data? Who might be interested in this data? And also, why is this data the way it is? And once you have the foundation, then we can start answering these questions and grouping that information together, or putting a system on top which aggregates and extracts all this information and puts it together for us. But we need to be descriptive first. We need to have good hygiene to fill in the blanks about what things in our system mean. So it's not just like the code. It's not just the documentation of how to deploy a pipeline or run it, but also the things that it's doing in that pipeline, the data that is moving around, and then what does this data mean, and what does this data do, etc., etc. So we now have multiple systems that are using data, that are moving data around. We have multiple pipelines that are being generated based on configuration objects. We have labels, we have metadata, we have multiple definitions of our data, like our schemas, where most of them are together in one repository, but there's also a couple which are somewhere else. And we now are starting to see like patterns emerging. And we need to start bringing all this information together. So the information about who owns the data, who manages it, where does it come from, where does it go to, and if it goes somewhere, what does it look like, which schema should it use, which data set is it, are there certain other like limitations or constraints there, put them all together. Also things like, what is it about, what is the data about, what does it look like, etc., etc. So we have all this information. It's kind of scattered a little bit across different systems, and we need to bring it together. So one model to rule them all. One model which has all the information about like a data object, describing what it is, where it comes from, where it goes to, who owns it, what are the labels, etc., etc. So all this information that our different systems have, we need to combine them together, so that we get one abstraction that all our systems can use, that we as people can observe in one go and share in one go, that has all the information to build this data object, but also to understand it, and to know how to ensure that it is of good quality. And then this can trickle down to the rest of our systems. All our other systems can then use the information from this model to automate it and implement whatever they need to be doing. So we now have a reliable and descriptive, but also an extensible and a dynamic data platform that has testable and observable data, that is centralized, and shared data models. And most of all, over those 2.5 years, we have loads of lessons learned about how to go about this DataOps paradigm. And we did it all together as a team, multidisciplinary team, where we really helped each other to like achieve the best solution, but also achieve the best from ourselves. What's next? Maybe MLOps, because now we have this stable foundation, we have this qualitative data, and we can start doing more interesting things with it. But that's a story for another time. So all drawings were made with XCaliDraw, which is an open source browser-based drawing and graphing tool. I really like it, so check it out. And remember, just be pragmatic. At least I'm always pragmatic, or try to be, and have lots of fun. Thanks.
Okay. I will turn off your screen. Thank you very much, Tim. That was really interesting. Thanks for taking us on board your DataOps journey, and also for teaching us on how to overcome some challenges related to data quality and data discovery in DevOps. Okay, so we have already, or the first person posted their question into the chat. I'll just blend it into the screen, and yeah.
All right. Thanks for your question. Yeah, so adding direct value, we could identify which data sets were being most often used, and for example, we could optimize them based on this dashboard data, these usage statistics. Also, in terms of business value, because we were now testing our data continuously, we could more quickly identify issues with data which would otherwise go unnoticed, which would then maybe cause wrong insights, which the business would then act upon. In those terms, we did add direct business value, I guess.
Okay, thank you. So if there are any more questions, just drop them into the chat and we can display them here on the screen. It always takes a few seconds until the participants can hear it on Twitch. So maybe let's wait a few more seconds.
Okay, that's fine. And otherwise, you can always find me on Twitter or on LinkedIn if you have any questions afterwards. Or you can find me in the Data on Kubernetes community as well. I'm a very proud member there. It's a really nice community, but we're already talked very enthusiastically about it. Every bit about it is true, so definitely come check us out there as well.